welcome. Now this is a new section, and it's going to be different from the previous ones because all the speakers are going to be remote. First of all, can you all hear me? Yes, I guess so. Good. We're going to have 3 speakers that are going to talk about what the work is now that it's being done on IPv6. So first of all, we will have Jen. Jen is going to start sharing her her camera in a moment, and then I see that her microphone is already open, and then she'll be able to also share the screen. Oh, you cannot hear me.
Yes, I can hear you.
The mic is on. The mic is connected. Yes. Oh, okay. 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 That sounds good then. Okay, Jen. Now you can start sharing. Yes. So please do.
Okay, request control. Share my
Okay,
screen.
Jen.
Okay, yes, just a second. Share.
Jen is going to talk about IPv6 only in enterprise networks. I'll let her start right now. So I see that you have the floor. You have probably the mic. Let's test the mic.
Yeah, can you hear me?
Jen?
Can you hear me?
Okay, good. Okay,
Good.
then yes, then I'll leave the scene to Jen. Bye.
Okay, hello. So today I'm going to talk about kind of gap analysis for V6 deployment in the kind of the networks which probably left behind an enterprise network. So to be honest, every time we talk about IPv6 and enterprise, I have a really strong deja vu. 10 years ago, when I was working for a large network vendor, every time I was talking to customers about wireless deployment, like, would you like to deploy wireless access points and give your engineers and other people in wireless access? Engineers were, no, we don't want this. We're quite happy with our Ethernet RG45, and we do not want this strange wireless thing because it's uncontrollable, it's insecure, we are afraid of it. But the problem is they already had it, because I saw the people just plugging into the switches small boxes, which provide them with totally uncontrolled wireless connectivity. So they had it, but they did not know about that, they did not control it. And now we have absolutely the same conversation about IPv6. No, we don't want this IPv6, we're happy with IPv4, and it's insecure and we don't need it. The problem is, in many cases, they actually have it already again, because almost every user device nowadays has IPv6. So if you do not deploy IPv6 in controlled manner in the corporate network, your devices still have it, but you do not control it. So why? Why we still do not have enough IPv6 deployment in the enterprise? If you ask them, you will see the same well-known picture of IPv6 bingo. You'll get the same answers over and over again. We don't need it, we don't have money, we have other stuff to do, and so on. But among those answers, there are indeed some non-technical things, and it's mostly mindset. But there are also some technical issues which might slow down IPv6 deployment in enterprises. And I've been talking to various enterprises for a while, and I think from my experience, we have a kind of top 4 issues which not probably prevents, but do slow down IPv6 deployments. So, first of all, enterprises want to control network access, and sometimes they believe IPv6 prevents them from doing this. Secondly, we have 2 network protocols. You have twice or maybe even 4 times more things to care about. Third issue, actually becoming more and more critical, it's a multi-homing, and I'll talk about it. And indeed, yes, there is always something which does not support IPv6. So let's look at them. Network access, not even actually control, I would call it surveillance. Every time I talk to enterprise engineers about IPv6, they say, no, wait, I do not want this v6 because with IPv4 I have my DHCP, so I know which device uses which IPv4 address, and in IPv6 you have this crazy stateless auto-configuration thing, and even worse, privacy extensions, and we do not know who is doing what. And to be honest, I think we again have non-technical problem here, more like mindset issue. We should not be confusing host stack configuration protocols like DHCP or Slack with network access control mechanisms. If you need to know which device or actually which user was doing what, this information is present in your network and you can access it. First of all, in the controlled environment when devices are under centralized management, it does help to use .1x or any other form of authentication, which will at least provide you some information which user was using, what users were using what devices, right? Because I think in IPv4 world, engineers believe that I can identify MAC address and I can identify device. It's not actually the case anymore because a lot of devices do MAC address randomization right now. So knowing just MAC address does not tell you much. I personally changed MAC address on my laptop at least 10 times in the last 2 years because every time I'm getting to the airport Wi-Fi when they give you half an hour of free internet per MAC address, it's just so easy to change MAC address and get another half an hour. So I think the combination of user authentication plus getting neighbor cache information, which actually tells you MAC to IP mapping info, would allow administrator to identify users and their network activity in both v4 and v6. So it's not a really problem if you look at what we have currently. And as far as I know, for example, if you ask me about vendor support, JNIS starts supporting streaming neighbor cache information in their telemetry, starting from 18.1R1, which I think has been released. I was told that Cisco actually can log neighbor cache changes as well, but I have not tried that, so I could not confirm. But yeah, basically, all that information is available, so it's not really a blocker. Second problem, oh yeah, it's a big one, dual stack is hard. I've heard so many times, oh, we've just disabled IPv6 in this network. Why? Because we wanted to troubleshoot and we cannot troubleshoot two protocols. With all these happy eyeballs and other stuff, we just do not know if it's v6 or v4 or something else. And to this, I have an answer which might sound a bit extreme. And I would say we probably should consider moving towards IPv6 only. Because yeah, two protocols are hard, and if I have to choose one, I'd rather choose IPv6. I'm pretty sure a lot of people are thinking right now, it's not even possible. Well, it's actually kind of possible. It depends. It depends of workflow, of network usage scenarios, and so on. For example, we do know that most of phones, modern phones, do very well on v6 only because they connect to v6 only mobile networks in many cases, right? And web-based applications also work very well based on the testing and pilots I've done personally. Currently, the most issues are related to desktop applications, yeah. But it means it's just time to talk to vendors. I can remember when network equipment did not work with IPv6 very well, but we made it here, right? We talked to vendor, we got the bug fixed, and so on. And I've been involved into running a number of experiments on IPv6 only conference networks, and it looks like the biggest gap we have now in enterprise environment is VPN. And not because VPN as technology could not work on IPv6, it's mostly because enterprise network administrators are very, very creative when it comes to VPN configuration. On one hand, obviously, VPN is you use VPN to access your corporate network from outside, right? Well, the second fact we should be aware of is that there are IPv6-only networks out there, which brings me to conclusion that ideally VPN should allow you to connect to a corporate network from IPv6-only network. But in many cases, it's just not possible. And again, VPN, IPsec or SSL VPN itself has no problem with it as technology. The problem is either vendor support or VPN configuration. What I've seen so far, some VPN servers just not willing to establish any VPN session if client doesn't have IPv4 address. It just, everything goes well until some stage of negotiation when server like, no v4 address, I'm not gonna talk to you. And when you ask vendors, they're like, yeah, we do not support this. We just do not have that part of the code written. Second thing, split tunnels. VPN split tunnels considered harmful, really. Because what normally happens, client connects to VPN server, gets some corporate DNS servers, start using them to resolve everything, right? Including, let's say, Facebook or Google. But the traffic to Facebook or Google is not sent through VPN, it's sent directly. In this case, if your client is in an IPv6 only, not 6.4 network, it just got broken, right? Because your corporate DNS has no idea about DNS 6.4 functionality. So basically it's a problem, and I would say in IPv6 only environment that rather not using split tunneling is not such a great idea. Third very interesting scenario I've seen was when Corp DNS servers just did not return any quad A at all. So you ask for Facebook, for quad A for Facebook or Google, and you just get nothing, only A record. So basically DNS server is for some reason lying to a customer. Well, I think it's, again, not such a great idea in general, and it definitely breaks IPv6 only clients. Third issue, multi-homing. If it's an enterprise networks, normally do not want to become LIRs, right? They do not want to spend money and resources on this, so they want to use provider address space. And if you're connected to multiple providers, you obviously start using multiple provider prefixes, and then you have two big problems. First, how to send packet the source address of one ISP to the correct uplink. I mean, sending it to the uplink which belongs to that ISP. Because otherwise, if other ISPs implement BCP38 anti-spoofing filters, the packet might be dropped. And the second problem, what to do when an ISP uplink goes down or comes back up. So, for sending packet to the right uplink, there are many ways you can do that. The simplest one is the standard policy-based routing. There is other technology like source address dependent routing, which has been developed by IETF currently, or you can use IPv6 segment routing actually if you want. So the third, sorry, what have I just done? Okay, sorry guys. For reacting to uplink failure and recovery, obviously if uplink to an ISP1 fails, you just should not be using source addresses of that ISP, right? You need to signal back to host that those addresses are not available. And when uplink comes back up, you need to tell host that those prefixes from that ISP are available again. So I've been working on a kind of tactical solution for this, which is called conditional array. And actually, I think I even have a link to the document in the slide. But there is a much more elegant long-term solution which is being developed by IETF, and I think Eric Wink is the right person to ask about it, which called multiple provisioning domains. So, tactical solution, what we can do if you need multi-homing right here, right now, without upgrading any of your hosts to most recent software release. The idea is quite simple. Let's use Slack to signal the prefix status. If uplink to an ISP is not operational, it's down, then the router needs to send an array with preferred lifetime 0 for this prefix, which signals to host then that all those addresses from that prefix should be deprecated and not selected for new connections, if possible. When uplink comes back up, router starts sending arrays with non-zero preferred lifetime for this prefix, so hosts can use addresses from that prefix. Well, quite simple. There is a link to the draft, and I actually presented this approach at RIPE a couple of weeks ago, so there is a video of my talk. Multiple provisioning domains. Much more elegant idea. Basically, even if your host is connected to network via just one interface or multiple interfaces, even in case of one interface, it still might be that this one interface connects the host to multiple logical networks, and each network has its own set of configurations. For example, in case of a multi-homed enterprise, my laptop connects via its physical wired or wireless Ethernet to a switch, but the network could provide me two sets of prefixes from one ISP and another ISP, and maybe even each ISP provides its own set of DNS information, and so on. So multiple provisioning domains allows hosts to detect that it's actually getting connected to different logical networks and combine all that information together. For example, if a host is using DNS servers of ISP A, it does make sense to send packets, send DNS requests from the source addresses of ISP A, and then send traffic to destinations resolved via that DNS server via ISP A again, right? So it actually might solve all these split horizon VPN issues which I was talking about, but it's a new work in progress. So unfortunately, we cannot just rely on it being available on every single device in the corporate network. So yeah, legacy systems and applications, and probably the biggest issue, right? Well, the solution is the same as for routers which did not support IPv6 like 5 years ago, right? We need to start doing it now. We need to identify which applications are actually broken. We need to file bugs, and it's actually the perfect time to start adding IPv6 as a mandatory requirement to your documents when you select new vendor or qualify new applications. And after you did all that stuff and you get IPv6 deployed on your corporate network, there is one more thing. When you think you are done, you're actually not done yet. Because what I've seen quite often is that people configure IPv6, run IPv6 ping or traceroute, even go into testipv6.com, run it, say, oh, okay, 10 out of 10, I am done, and walk away. And 5 days ago, everything is broken, but you do not notice it because happy eyeballs tend to hide the issues. So, first of all, you need to make sure that whatever you configured is actually working. So end-to-end kind of connectivity tests are helpful. And it does make sense to talk to your system owners to find out they're actually using IPv6, because I've heard conversation like, my network is fully dual stack, network infrastructure is ready, and service owners have not even enabled IPv6 on their servers. So network is not everything, right? So you need to think about applications and talk to applications owner and monitor what you've done. And I think that's it for me. I'm not sure if I'm on time.
Hi, Jen. Yes, we are a bit we're a bit late in the schedule, but that's fine because there's been also a lot of discussions in the chat. As far as I can tell, there were no questions remaining now. So actually, people debated about some of the solutions here. So you can later now, after while Jordi is talking, you can also scroll back into the chat and have an idea of what was discussed. So, are there any questions you might want to ask directly to Jen now? And if so, please, can you type them? See if we have anything. I did see someone typing, but it looks like there are no questions for now. So thank you very much, Jen. That was really interesting. Now we have instead Jordi. So Jen, you can turn off your microphone. Good. Now we have Jordi. He's presenting a different set of works he's doing at the ITF level. Jordi is very active, very active in at the ITF and at the in the RIPE community as well. So I'll let Jordi talk about what he thinks is going to be happening under the IPv6 transition. There has been some discussion. There have been discussions also in the chat about this, but I'm sure he can give you more insight into that. Jordi, you have to enable your microphone though, because we can't hear you.
I think it's enabled. Yes, can you hear me?
Yes, now we do.
Okay, perfect.
So what about the camera? Are you going to enable the camera?
I am running a difficult setup, so it's difficult for me right now.
That's okay.
I have to.
That's okay.
Screens to be able to see what I am presenting.
That's okay. That's
okay.
Okay. So Jordi, please, I'll leave you the stage.
Okay. Thank you. When we started to develop IPv6, we were talking about transition and coexistence, and we all know that at that time we talked basically about dual stack, IPv6 in IPv4 tunnels, and translation. At that time, I remember when I was training IPv6, that was around 2001 already, I was telling everybody, don't use translation. We better don't go to that path. We break things and so on. And we also were telling people, again, you do tunnels and you encapsulate IPv6 in IPv4. Another interesting thing that I was trying to tell the people is lots of times people get confused when you use migration. Migration is not the right terminology for this situation, because migration is like when you move from Windows XP to Windows Vista, for example, and you remove Windows XP, but we are not easily at this stage removing IPv6, so you cannot really do that. So, and in fact, the ITF wording for all the transition mechanisms is transition and coexistence. Never we use migration for the mechanism itself. Sometimes in the documents you see migration, but not as a way to mention the transition mechanism, okay? So what happened in the last years is that we have been doing that. Basically, we did most of the time tunneling, but right now, when we run out of IPv4 addresses, we cannot do anymore this kind of tunneling. We cannot use any more IPv4 networks to, on top of them, use IPv6. So what we are going to see right now, and it's something that is already happening, is the reverse way. So we are doing IPv6-only networks, and on top of them, we tunnel IPv4 packets. And of course, we need, unfortunately, to use some kinds of translation. So this is the situation right now. We don't have any more IPv4 addresses, and we cannot use those kind of tunnels that we were initially recommending. So if we look at the recent development in terms of transition mechanisms, and I put them here in the slide in the order of how much they are being used. The most recent one, which is 464 XLAT, is actually the transition mechanism that have more users. And in fact, in terms of server users, it has hundreds of millions of users. So it's even much more than all the other transition mechanisms altogether, right? Then we have, of course, a lot of usage of DS Lite and the successor of DS Lite, which is a simplified version, which is Lightwave 4/6. And then the last two mechanisms that have been defined, which is MAP-E and MAP-T, they have some usage, but really very small usage in terms of number of networks using it and number of users. It seems to be growing a little bit, but not really that much. There is also some initial work of 464XLAT in wired broadband networks, because most of the people, when they hear about 464XLAT, they believe that we are talking only about cellular, but this is not the case. The RFC perfectly defines and clarifies that it's possible to use 464XLAT in both cellular networks and non-cellular networks. So what we need for this IPv6-only scenario to go on? Well, we need the ISPs to run NAT64 if we are working on the scenario with 464XLAT, which I think it's the one that will be more common in the next coming years. And again, not only in cellular networks, but also in wired broadband networks and wireless networks and all kinds of networks which are not just cellular networks. So the ISP run NAT64. This is also possible for the enterprises. So if enterprises want to deploy just IPv6 only, they could do that also with NAT64. And if they are going to use just NAT64, they need DNS64. But if they are using 464XLAT, then DNS64 is an option, okay? I have a document right now in V6Ops, which is describing those scenarios. I encourage you to read that document and provide inputs. The other thing that we need to make possible this situation of IPv6 only is the support, especially for small routers, for the CPEs that residential users and SOHO, small business, medium business, and sometimes even big corporates are running, is those routers to support those new transition mechanisms. So we have now a working group item in V6Ops as well, which is precisely recommending, as a kind of upgrade to the previous IPv6 customer edge router support document from ITF, the support for IPv6 as a service in IPv6 only networks. And then finally, for the people that need to support in data centers also IPv6 only, which is again something coming more and more frequent. For example, we have the case for Facebook that already run only IPv6 in their data centers. We have different solutions, but I think the most common one in the next coming years will be SIG-DC. So that's the picture of the scenario of what we are going to have. And in addition to that, because I am a strong believer that 464XLAT is the one coming on, I have this situation already under trial with some customers where we have a 464XLAT multi-service network, because what it don't make too much sense is if you have a cellular network which only support 464XLAT, because unfortunately MAP-T, MAP-E and other transition mechanisms are not supported by any operating system in cellular networks. So you have only one choice, and then you don't want to have a different transition mechanism for your residential or corporate customers, okay? So the situation here is if we have the CPEs or the router supporting CLAT, which is the client for the 464XLAT, and then you have the NAT64 and optionally the DNS64 in the ISP network, you can have the same situation where you have an IPv6 only network, at least in the access, sometimes even in the distribution. And if your corporate networks are using the network basically for browsing, which is most common situation, or even if they have some services that they need to present, which IPv4 also to outside of the network, they can use either 464 lat or a combination of 464 lat with SID-DC. Okay, so this is possible. We have tried this, and we have right now about 10,000 customers in 3 different ISPs with a similar scheme as the one in the slide. So for those that are not, they don't know how 464 lat, basically what this is doing is you have in the server phone or the router, you have a CLAT client, which is doing, when needed, a stateless 4 to 6 translation. Then you have the ISP network, which is IPv6 only, and of course the IPv6 traffic goes straight from the server phone or the router or the LANs to the IPv6 internet, and then you have the PLAT, which is a NAT64 translating from 6 to 4 for those end sites in internet that have IPv4 only. So we have 3 possible application cases, which is what it matters at the end. You have a situation where both the client and the server have IPv6 support, so in that case it's native IPv6 support end-to-end. We have the situation where we have applications that have support for IPv6, like a browser, for example, but the destination is a website like most of what we have today that have IPv4 only support, and then in this case only NAT64, and optionally the DNS64 is doing the translation, okay? And in the case of applications using literal IPv4 addresses or all APIs, or if you don't want to break DNSSEC, you can force those applications to run through the CLAT and then again to the PLAT. So this is the situation of the 3 possible scenarios for applications running on this network. Now, a very quick explanation of how you do an IPv6 only data center. What we do basically is we map all the IPv4 internet, which is 32 bits, in a /96 IPv6 prefix. So that means basically every address in internet will be able to reach an IPv6 only server because this mapping, okay? How about availability? Well, NAT64 is something very well supported. So there are different vendors and also open source tools. My preferred open source tool is Joule. And regarding the CLAT, we have support for that in Android, in Nokia, in Windows, not yet in Apple, but Apple is doing in a different way because they are forcing all developers of applications, if they want to stay in the App Store, they need to support IPv6, so then we don't need that in theory. The problem comes when you need to support tethering, that you may have devices using the tethering which are IPv4 only, so that's a different problem. And then we have OpenWRT, and this is the way we are doing right now the trials I mentioned before, because most of the vendors up to now, they are not supporting CLAT in the CPE, so we need to reflash the routers with OpenWRT, and that's the solution, the easy solution. It's not the best way for some ISPs to control OpenWRT, but I know there are different vendors like Linksys, D-Link, Zyxel, NAC that are already working in supporting CLAT, so that's something coming, and also from the work in V6Ops, I hope that more CP vendors work into that. And of course we have a lot of commercial deployments and trials, and as said before, 464xLAT is actually the one which has more users compared to all the other transition mechanisms together. I added this slide, which is not about transition, but I had a similar presentation to the one today, yesterday in LACNIC, and we got some questions about this. So there is the RIPE 690 VCOP for the people that want to understand how or which considerations they need to take for defining or deciding how to number point-to-point links, and also how to number customers, if they want to use global addresses, ULAs, and also I have another V6Ops document working on that. Please read that and provide your inputs. And I think that's it. I'm not sure if I did correctly with the timing.
Hi, Jordi. Yes, we are pretty okay. Now, there are two questions that I can relate to you. So the first one, which you partially answered during your presentation, but I think it's still nice to have it and to ask you directly. If you, in your implementations, if you're doing it for your customers, what hardware or software are you using for your implementations?
Okay, there are two parts. One part is for the ISP network, which is the NAT64, because DNS64, in most of the cases, you don't need that. But even if you need DNS64, for example, Bind or other very common DNS server, they support it. So that's sorted out. For the NAT64, you have either some vendors. I have one slide which I mentioned of a few of them. I think Juniper, Cisco, A10, F5, all them support NAT64, so this is very, very common. And we have an open source, and in some of our customers, we are running Joule, which is an open source implementation of NAT64. And then we have the part that goes into the customer. If you are running just a cellular network, the cellular phones, which Android and Windows already support the CLAT client, so that's done. But if you are running an end user's network or which are not cellular phones, you need a CPE, a router that supports it. Right now, the best option, the simple one, is either asking your vendor if they already support it. Sometimes they can provide a firmware that it's maybe not yet commercial, but at least for some trial, or use OpenWRT.
Okay. And the other question, which Eric already answered partially, is does the IPv4 subnet have to be associated to IPv6 for the translation to be successful?
I don't really understand what do you mean with that question.
Yes, well, it doesn't come from me. I'm relating a question from the chat. So the question was when you were present. Oh, I think there's Sander took care of that already, it seems. But now there's a question from Sylvia Hagen.
Okay.
Do you know of commercial deployments of XLAT and NAT64 in the enterprise?
Well, what we are doing right now is trials. I heard that somebody has done some commercial deployments, but I don't have data that really I can share because I have not confirmed it by myself. But somebody told me that there is some. Well, I recall right now just one that was mentioned in the NANOG mailing list. It was a wireless ISP, which is called Wireless Mesa, and that's in I think it's Texas or something like that. So they reported that they are doing that in the NANOG mailing list.
Okay, I think Mesa could be Arizona. In the US.
Maybe Arizona, maybe. Okay. Yeah.
Okay. Are there any other questions here for Jordi? I don't see anyone typing. So, well, thank you very much, Jordi. You were perfectly on time. We are running a bit late, but it's okay. We're going to be 5-10 minutes late, but that's normal in when you go live. So,
not a problem.
Thank you very much, Jordi. Thank you very much. So now we're going to move over to Tim Chown. He's going to also present about what's happening in IPv6. I see his phone is okay. He's muted right now. Not anymore. Yes.
Is the audio okay?
Yes, we can hear you. I can hear you.
Share my screen.
Yes. Okay, so I'll leave you the stage. Thank you very much.
So yes, what I will talk about for a few minutes today is some reflections on 6 years of IPv6, what's happened in the last 6 years, and just some perspectives on that. So yes, I'm work for Jisc, which is the UK National Research and Education Network, as Network Development Manager there. And I'm also co-chair of the UK V6 Council with Veronica McKillop, who is there in the chat window. So yes, I'm just going to give you a few reflections from the last 6 years. One of the things that struck me when someone invited me to talk was, where did those 6 years go? It doesn't seem 6 years ago that we had the World V6 launch. Time has certainly flown by. And as you can see from the Google chart that you've seen before today, and no doubt you'll see again today, we've seen some pretty good increases in usage. We're well over 20% as far as Google goes now. And I think looking back 6 years, if you said to people, if we're at 20 to 25% in 6 years' time, I think most people would have taken that and been very happy. And as Eric's talk shows, the graph is continuing to go up. It's worth just also reflecting on the fact that V6 hasn't just been the last 6 years, of course. It's been something of a long tail of activity before June 2012. Perhaps tail is the wrong word because that suggests something at the end. Perhaps you sort of want the aardvark's nose of V6 at the front of deployment there. As there was some activity dating back to, you can go back to 1996 when the 6-bone was set up. That was before the IANA address space was handed out. It was a special prefix that was used and a great mess of tunnels for experimental connectivity. It was a fun time, but not something you'd want to use in production. And over those 15 years or so, we've gone through various projects and certain initiatives. And I would argue that most of the early deployment, though by no means exclusively, was in the national research networks, like Janet, or in France, or Renater, DFN in Germany, etc. And there was a great project called 6net that helped us deploy. And at the time, it was just the smaller, certainly in the UK, it was just the smaller ISPs deploying. But that's all proven to be good work and paved the way for where we are today. And just to reflect on the UK for a moment, if you look back to 2012, I think Veronica yesterday sent me an email where she said it was something like 0.1% was V6 at the time, and that was largely the Janet NREN plus some smaller ISPs. It was a really, really small amount of traffic, and we've grown now to be pretty much at the worldwide average in the UK now at just over 20% deployment in 6 years. Most of that, though, has come in the last couple of years. The first big ISP to go was Sky. They deployed over, I think it was a 3 or 4 year project, and now reach roughly 5 million customers dual stack. And now we're also seeing BT moving as well. They're at over 3 million customers dual stack. So that's a lot of homes in the UK now that have V6, which is great. And on the mobile front, probably most or many people on this webinar have heard in the States how the mobile operators there moved massively to V6 only in the handset using the 464 XLAN and NAT64 technology that Jordi was speaking about. That's the same in the UK. We have EE, which is part of BT, who are leading the V6 only mobile now. They have over 2 million users, paying real money to have a V6 only handset effectively. So this technology works. It works at scale with tens or maybe more millions of users. It's all, it's out there and it's working. And if you want to see more about what the UK Council is doing, go to our website there. And there's also presentations at the UK North. There's quite a lot of those about V6 as well. Veronica has also just published today, as part of these celebrations, the 6th anniversary. There's now a new blog on our council website reflecting back on the last 6 years of growth in the UK. So go and read Veronica's blog there. It's really good. And we're also planning an event in September. I think it's the 25th on V6 transition. So that'll be in London at Imperial College. Come along. Interesting also to look at some of the stats of how things have grown. The Google stats are very good. They let you look per country. So you can see just over 2 years ago, the UK was only at 2.7%. And roll forward to today, and we're at over 21%. So it's a very, very good growth, largely Sky and BT, but we mustn't forget other people as well. Something many people might not be aware of is that now Facebook has started producing stats in a very similar style to Google. So you can go to facebook.com/IPv6 and see a similar type of representation there, and their numbers tally quite well, 21.6 versus 22.3 for the V6. That's the percentage of V6 of traffic in the UK hitting Facebook that's over V6. That's pretty good. And another, just final, I'll mention it. I know Eric covered measurements quite well in his earlier talk, but the APNIC measurements are also a really good source of information. If you go and look at those, they produce these stats, I think, by placing advertisements that allow them to see how people are accessing those advertisements, whether they're available V4 V6 only or dual stack. So they show slightly higher numbers, but it's pretty much in the same ballpark. And you can clearly see the growth in the UK there. If you also scroll down on those AP-NIC stats, one of the interesting things there, if you're interested in how V6 is going in your country, is you can see reports by ASN, or therefore by ISP, of what's happening. So you can see at the top there, Sky UK, 93% of their customers are V6 capable from all those advertisement data they've got, and about 37% of BT. So you can imagine if BT get to 90-odd%, we could be at about 10 million customers there with V6, which would be great. And you can see Janet down there, the NRN, with 6%. We're there, but convincing universities to deploy is an interesting topic. We deployed V6 on the backbone of the academic network way back in 2002 as part of that 6net project. And while there's clear cases you can make for universities to deploy, actually getting them to do it with all the other pressures and things that they have on isn't easy. So there's about a dozen or so universities that have done a good deployment. There's certainly business cases to be made around teaching and research. It's important if people are coming through university, particularly if they're doing computer science, to come out into today's world where V6 is important with that experience at university. Similarly, research projects. But sadly, at the moment, having led the way, those NRENs are generally being overtaken by the commercial ISPs. I just quickly mentioned that at Jisc we are seeing some interesting new deployment drivers emerging for V6, and one of the ones that's I think is quite exciting is that the the sites that are responsible for taking the data from CERN, the Large Hadron Collider, and processing and analyzing that in 4 major experiments, are now requiring that the sites that store the data distributed around the world support IPv6. That's a requirement that's supposed to be delivered this year, and that's largely happening. There's a working group there. You can go and read more about that, about how they're making that happen. And they've taken 2 or 3 years to get to this point, but they had a bit of vision, and they're now benefiting from that. And for example, at Imperial College, they're showing they can take in up to 40 gig of certain data per second over V6. So that's some pretty serious research traffic happening over V6 today. So for the second half of what I just want to talk a little bit about today, so some reflections on how V6 is progressing in the IETF. I mean, you heard Bob probably speak at the start of today. He talked more maybe about the history of how we got to IPv6 from all the other contenders. I think one of the important things he said was that the core protocol document, RFC 2460, that was published in '98 and has recently been updated to RFC 8200, hasn't changed very much. The core standard has proven pretty stable over 20 years, and stable enough that it's been promoted to a level called Internet Standard. Most RFCs are proposed standard. Internet Standard indicates a much more significant level of maturity. So that's a really good sign from the IETF that they've promoted that core standard to Internet Standard. But obviously over those 20 years, we've had a lot of experience from deployment, particularly in the last 3 or 4 years. And those have led to some enhancements to the V6 protocol, but not as the core protocol. Those are things on top of that. And also some changes in thinking. I'll give you a couple of examples of those in a moment. And therefore, there's still ongoing work in 6man and V6 Ops, as Jordi has mentioned, on progressing those sort of ideas. So just as some examples of how things have progressed, back in 2011, just before the World V6 launch, people were aware of the fact, for example, that there was a problem with rogue route advertisements. Any host can potentially pretend to be a router and attract traffic, even in a V4-only network now, because all devices support V6. So work was done to define ways of protecting against that. But as ever with security, there's always, you need to stay one step ahead of the way that the hackers may be thinking. So having implemented RA Guard as a means of preventing rogue route advertisements getting into the wrong parts of your network, the attackers then noted that, well, if you present a route advertisement in a fragmented way, use lots of extension headers, you can bypass those protections. So, and again, the IETF reacted to that and proposed an RFC to deal with that. But the interesting thing is, and there's a really nice talk, a blog on the RIPE site there that I've linked to, not every ed vendor has implemented this advice yet. So that's an ongoing thing, but there is a constant, I wouldn't say battle is the wrong word, but there are always security issues in any protocol, and it's a matter of keeping up with what's happening. Similarly, there's another RFC I was involved with here, 7707. That talks about scanning in V6 networks, and you'd think with a 64-bit host identifier that scanning 2 to the 64 addresses is not so feasible. In practice, however, because of the way that people assign addresses sequentially starting from 1, the way they form their address plans, the way that in some cases UI64 MAC addresses are embedded in addresses, those types of things, actually the scanning is not as difficult as you might think. I won't say any more on it other than to suggest that you go and have a look at a really nice toolkit from Fernando Gont's site there, SI6 Networks. There's lots of tools there that if you're interested in hacking around, you can go and download them. And then just finally, my last 3 or 4 slides, I'd just like to quickly reflect on some things that are happening in a draft I'm working on at the moment. This is the update to the IPv6 node requirements. So this is happening in Bob Hinden's working group. This document was last updated in 2011, again before World V6 launch. So we've looked at it and realized there are things that have changed and we need to reflect those in this document. The document describes the protocols that a generic node should support to support IPv6. The good news is we progressed this through the IETF now to the point where it's with the IESG, which is the technical body responsible for reviewing drafts before they're finally published. So hopefully this will pop out soon as a new RFC. But what sort of things have changed? I think there's a couple of things that I'd like to highlight in particular. One is the ways that you generate V6 addresses. Back in the early days of V6, the stateless auto configuration embedded MAC addresses in the host part of the address. That was quickly recognized as a security issue, so then we had privacy addresses to deal with that. But if you're operating a network, there's this tension between balancing the privacy with the ease of management. If your devices are changing addresses regularly, it's less easy to understand what's going on. Jen did say that if you want to do accountability, using stuff like 802.1x is almost certainly the way to go. But there are a lot of people that, for example, have relied for many years on using DHCP address mappings for some level of security, and they want to see some kind of equivalent. So RFC 207217 has come along and now allows Slack to work using stable per prefix interface identifiers. So whenever you're on the same prefix, the first 64 bits, the interface identifier used will always be the same because it's based on a hash of that prefix. And RFC 8064, which was published last year, recommends that anyone doing Slack uses that new method, not the one that embeds the MAC address. But you can still use privacy addresses as well as you want. So that's one thing that's come up since World V6 launch. And another one is an emphasis on allowing hosts, if you're a provider, to have multiple V6 global addresses and not limit them to one. If you limit them to one, it'll encourage things like NAT to happen. So much better to be generous with allocating addresses to hosts than force them into using that. So there's a couple of RFCs there you can look at that are related to that. And if you are watching this as a provider, I'd encourage you to look at those and think about supporting multiple addresses per host. And from the point of view of 6434 BIS, we've made that a should, not a must in the document, but we're encouraging it as strongly as we reasonably can. There's a few other things, but we're not, as we're running a little bit behind, I won't go into those now, but have a look at the slide deck later. Just the last point there, privacy is something that's very important in the IETF these days. Snowden actually happened after World V6 launch day, so this push on privacy in the IETF and things related to V6 has happened since the launch. It's worth remembering that. So just finally some closing comments. It's great to have today where we're celebrating 6 years of good growth in V6 since the World V6 launch. I think it's fantastic that RIPE NCC have pulled this together. I've enjoyed listening to the other talks so far.
Thank you very much.
There's obviously
Tim,
still a long way to go, as others have already said. And
I haven't seen any
long
question
time,
in the chat so far. I see someone is typing, so there might be
the
something coming in.
The core protocols have been very stable.
Let's see.
And as we've gained deployment experience, we've enhanced V6.
That's it.
The IETF
So
community has.
I have
been
a
some
question
changes
for
in
you.
V6
There's been
well,
first of all, you say we have to encourage ISPs to assign more addresses to end users, and that's true. We try to
whatever
convince everyone at our training courses about what needs to be done to enable
Thank you very much for
IPv6.
listening.
What are the best practices there? And there's also a document from the RIPE community showing what's the best way to do prefix delegation. Sorry, and how to assign addresses. I see Jordi typing, so maybe he wants to chip in with the link to the yes, RIPE 690. So that is a good recommendation, and I wanted to point people there. But
okay, thank you.
It comes out of the same work as well. Yes. And also Sander, who participated in that, is here. Jordi, so you can see many people here have something to say about that. Yeah, so just I just wanted to add this to your presentation. But thank you very much, Tim. Yeah. Yes. Exactly. So, well, with this we finished the presentations for this section. If there are no questions, then let me anticipate. We're going to have a break for lunch, also for you. We'll be back in about an hour and a half. We'll be back at around 12:30 UTC, or locally in Amsterdam for us will be 2:30. So you can relate that to your local time. We're taking a long pause for having lunch and let you maybe deal with anything you might have to do in the office. Have some work to do or some phone calls to make, and we'll see you in about an hour and a half for a very interesting afternoon. We have two sections. One that's a very large section where we have people who have implemented IPv6, and so we have success stories for you to see. So stay tuned. We'll be back in an hour and a half. So we'll leave you can leave your screen open and everything. We'll be cycling the agenda. If you have any questions, write it in the chat. We'll also take a little bit of a pause to have lunch on ourselves, and I'll see you later. Thank you very much.